Thank you so much for joining us for this webinar, Advanced Lithium Storage Made Simple with Fortress Power and Morningstar. For Fortress Power, our presenter is Alex Lepore, who is the Western Sales Manager, and presenting from Morningstar is Jake Sherry, Application Engineer. Please know that a copy of this presentation will be emailed to all attendees along with a link to the recorded audio of this presentation. We will be answering questions at the end of the webinar, so make sure to post your questions in the questions tab. So without further ado, Alex, please take it away.
Jamie, thank you for the introduction. Everybody, welcome to our webinar today, and thank you for joining us. So, Fortress Power, who are we? We are a world-leading battery manufacturer who brings automotive lithium iron phosphate batteries to the energy sector. So as you can see here, we are a Philadelphia-based company right outside of Philadelphia in a small town called Southampton, PA. This is our headquarters, so we have a 30,000 square foot facility. This is where we do a lot of the R&D, quality testing, and assembly of the different batteries that we provide. A lot of our batteries are made for the small residential and small commercial space. The cells themselves and the manufacturing of these batteries takes place here on this picture on the right in Shenzhen, China. This facility in particular has been producing lithium batteries since 2008. Primarily, this was for the automotive sector beforehand, but they are now moving into the energy storage sector as we have seen a lot of growth in energy storage, especially here in the States over the past even 5 years. So we are a Philadelphia-based company providing different battery options. There's a lot of different applications you can use batteries for, and I'll be running through a few of them here on this slide. So you can back up your facility. So normally, if the grid goes off and you have solar without a battery, your solar will stop producing per the NEC code. So what you can do with the battery is you can power your facility when the grid is off and keep your solar panels running during outages. You can also do this for a self-supply application. So you can have PV in a battery where the grid prohibits backfeeding for net metering. So it really allows you to maximize your PV production or store that extra solar power for later use. So throughout the day, you know, without a COVID situation, you'd be going to work, you could charge your batteries throughout the day and then discharge them when you get back from work at 4 or 5 o'clock. Depending on where you're located, you can also save money on your electric bill. So you can charge the batteries at off-peak times and then discharge them during peak periods. So for example, in California, there is a time of use rate, as it's called, you can see here. And essentially what they do is they charge you a certain rate from 9 a.m. to 4 p.m. And then from 4 p.m. to 9 p.m., they will charge you, instead of 10 cents a kilowatt, they'll charge you maybe 20 cents, 30 cents, or even 40 cents a kilowatt. So installing a battery can really help you avoid these peak periods of drawing electricity from the utility because you can discharge the battery to those electrical loads. There are taxes and incentives available. There is the 30% ITC, it's now 26%, but if you did file under the Safe Harbor rule in 2019, you will be able to enjoy this 30%, although it is now 26% ITC if it is powered by solar. And a lot of different states have state and utility rebates depending on where you're located. In Pennsylvania, we do not really have too many state or utility rebates for storage yet, but we are seeing a lot more utilities start to incentivize storage and battery backup as it is becoming more and more popular. So a lot of the typical applications that we see with batteries is off-grid, grid expo or backup, your typical battery backup, self-supply, time of use, or demand reduction for commercial projects. So there's a lot of different drivers for batteries, which is why we've seen such unprecedented growth even over the last 5 years. So we're seeing falling costs. So we're seeing companies like Tesla, GE, and Lockheed Martin are investing heavily in R&D and the commercialization of batteries, whether it's on the residential side, commercial side, or even on the industrial side. They're really starting to put more attention into batteries for these different chemistries, which I'll be touching base with later in the presentation. And with more deployment of batteries throughout the United States, we're seeing the battery crosses decreasing, especially lithium technologies. So we're really seeing the cost per kilowatt hours of batteries are really starting to drop as more and more batteries are being deployed for these different applications that I mentioned. And like I mentioned, there are a lot of new market incentives that are really letting batteries take the forefront, just like how PV was 10 or 15 years ago. So we're seeing different federal and state regulations favorable to clean energy or renewable energy, state and local incentives, just like I mentioned, maybe the SCHIP incentive in California, or there's another incentive in New Jersey, the SREC program, which is really starting to push for incentives for different batteries and solar. And like I mentioned, the time of use management is really starting to push for batteries to use the battery to discharge to help the end user save money over a certain period of time by discharging the battery during those peak periods. So we're really seeing, because of not only this falling costs and rising market incentives, we're really seeing that batteries are really starting to pick up a lot of traction, and the technology is obviously growing with these costs and deployment and these incentives following. So we provide 5 different batteries currently at Fortress Power. These 4 are currently on our line. So we have the eVault 18.5. This is probably our flagship product, our LFP10, our LFP5 48 volt, and then our LFP5 24 volt. So all of our batteries are a 48 volt battery minus this 24 volt one here on the right hand side. I usually tell people the reason why we can range from the small residential to the small commercial is because we range from this 5 over here, and this 18.5 can parallel up to 12 for 200 kilowatt hours. So on the side of this, you'll see like a 1.5 inch knockout, which will allow you to parallel the batteries for paralleling. And you'll see here the eVault is definitely popular because of this LCD display. So you notice that the 10 and the 5 do not have this LCD display, and the eVault does. The LCD display on the eVault will display things like the voltage of the battery, the state of charge, current, and the power. Now I mentioned you can parallel up to 12. So let's say you had 6 in parallel. What this would read here on the bottom is that the eVaults have a master-slave relationship with the batteries. So for example, if this was the master battery that we had, this would say master, and the other 5 would say slave. And then this parallel number would be 6, showing that there are 6 in parallel. Another cool feature of the LCD display is it has this safety feature here on the right-hand side. So let's say one day you walk into your utility room, or you're walking up into the battery to see how it's performing and your state of charge for the day, and you see that there's a light over here on the right, and it says LV. What this can help you do is figure out, okay, this is a low voltage issue. We're seeing something with low voltage. The BMS is reporting there's something with low voltage occurring in the battery. So this will allow us at Fortress Power, when you call into our technical support team and you ask, okay, I'm seeing LV on my LCD display, what should I do next? This allows us to diagnose the problem and properly troubleshoot and figure out those next steps to resolve the issue. The LCD display is also live, so it'll report live what the state of charge is and the current and the power going in and out of the battery. So really like this LCD display. It's very nice, and it'll shut off or go dark after like 8 to 10 seconds, so it's not constantly lit up, because that would certainly be annoying. And then this is our newest product. I mentioned we had 5, and those were 4 on the previous slide. So our newest product is the eFlex 5.4. This is a 48 volt battery, like I mentioned. So this unit, seen here on the left, is stackable up to 200 kilowatt hours and can be put in a server rack solution, as seen on this picture here. It'll have closed loop communication with the different inverters and can be used for residential energy storage, commercial and industrial power backup, railway, telecommunication, military off-grid applications. Hence the name eFlex. It's very flexible, let's say. It'll also have the ability to have data logging and a Wi-Fi app monitoring as well. So you'll be able to go online through our web-based monitoring to see what the battery's state of charge is and power output. So similar to that of the eVault, but this is all done through an app that we will have. This unit can also be wall mounted, put on the wall, floor standing, or put in a shelf mount solution, as seen here on the left. This unit will be available late June 2020. More questions about this can be asked at sales@fortresspower.com, and we'd be definitely glad to help out. So regarding lithium batteries, so one key thing that makes lithium batteries different than, let's say, a lead acid battery or your typical gel battery is the battery management system. So for example, in the eVault 18.5 and the eFlex, we use a contactor-based BMS. The contactor-based BMS, just like a MOSFET-based BMS, protects against overcharging and deep discharging, overheating, overcurrent, and short circuit and open circuit protection. The battery management system is essentially the safeguard to the battery to make sure that the cells are protected. The benefit of using a contactor-based, which has like a fuse and a switch that physically opens and closes, is that it can also do the communication with the different inverters we're compatible with, communication with between the units in parallel, and has remote monitoring. The cells in the eVault and the eFlex are a prismatic cell, while in the 5 and the 10 with a MOSFET-based BMS, it's a cylindrical cell. The only difference between the cylindrical cell and prismatic, although they're both lithium iron phosphate chemistry, is that the prismatic is a little bit more efficient and a little bit less space needed in the same amount of volume area. So that's why, especially with the eVault, 18.5 kilowatt hours is quite a bit of kilowatt hours. So it makes sense to use the prismatic cells to get as many cells as you can into one space. So keep that in mind as you take a look at different batteries and battery technologies, and make sure you take a look at their battery management system, as this is a really important part to the lithium battery to be considered. And here are some technical specifications on the 5 batteries that I went over. So I'm not going to go over each one of these, but some few key things I will want to point out is the battery voltage. So like I mentioned, they are all 48 volts besides this 5K 24 volt here on the right. The eVault can stack up to 12. The eFlex can stack up to 5. You can do 2 10s and 3 of the 5Ks, 48 volt and 24 volt respectively. The eVault will have that LCD display monitoring, and it'll also be able to use communication with an RS-485 cord with communication to and from the different batteries you have in parallel. All of our batteries come with a 10-year warranty in the continental US with 6,000 cycles. So I usually break this down and say if you cycled it 1 time a day, it would last around 12 to 15 years. So keep that in mind, and obviously with more depth of discharge, you're going to get less cycle life. That's something I'll dive into later in the presentation. So now I'm going to pass it on over to Jake over at Morningstar. Jake, if you want to start off here, we'd be glad to listen to you.
Sure, sounds good. Can you hear me okay?
Yep.
All right. So let me take you through the Morningstar slides here. Just as a little bit of an introduction on our company background, we've been around since 1993. And since then, we've sold over 4 million products, mostly charge controllers in various sizes and output capacities, which we'll give you a sense of later on in the presentation. We've sold these in over 100 countries, primarily for mission critical applications is where we really shine, especially with our high reliability and low failure rate. The applications we cater to include residential and rural electrification as well. We recently took part in a very large project in Peru, which I think is considered the largest off-grid project in history so far, at least. 200,000 homes we brought power to, and over 3,000 community centers, all totaling about over 1 million people in Peru that previously had no access to electricity, now have small solar home systems just to power, critical things like lights, cell phones, that kind of thing, little TVs, etc. We also cater to commercial and industrial applications, strong in telecom, oil and gas, and security. And then, of course, recreational, mobile, marine, and agriculture applications as well. We consider ourselves the charging experts. We definitely have the widest and most diversified product line within those manufacturers focusing on charge controllers. And we, again, as I mentioned, pride ourselves in having the lowest hardware failure rate in the industry. So going ahead here, this slide just illustrates Let me get the rest on the screen here. You can see a number of our competitors listed here and how they stack up, how we stack up relative to the breadth of our product portfolio. We have two different product series, professional and essential series sold globally. Those include 8 different lines of products, including over 30 different models. Many of them are application specific, very strong for particular use cases. And again, relative to our competitors you see on the screen, they don't offer quite the breadth of models to choose from or the applications covered. So again, Morningstar considers itself really the leader in the charging technology. Just to give you a closer look at some of our controllers that would be applicable to lithium batteries, we have both PWM and MPPT charge controllers. So you can see here, the ProStar and TriStar are programmable PWM controllers. You can custom program all of the set points for open loop lithium battery charging, which we'll talk about later on. And then all of our MPPT controllers, from smallest to largest, are also data enabled and can be custom programmed for lithium. So just to give you a little bit more conceptual idea of what we're responsible for, what the charge controller is responsible for within the system. Some consider it really the heart and brains of an off-grid system. You can see physically it is converting the energy, the photoelectricity from the panels into usable current to charge the battery. It can provide voltage conversion and boost. It can take high voltage on the input, high voltage, lower current, and actually boost the current on the output so that you get more power into your battery. And also, again, this keeps the battery from getting overcharged, keeps it at a high level of charging where it's continuous, but it doesn't allow the battery to be overcharged. And it also has the ability with some load control features to prevent over discharge of the battery from DC loads. You can see in this example, we're referring to AC loads that are powered through an inverter connected to the battery. This inverter happens to be our little SureSign 300 watt, 12 volt inverter. And again, that can power loads like lights, computers, fans, etc. But in many cases, as you'll see on the next slide, you may just have DC loads in the more industrial applications that we cater to, including telecommunications and oil and gas. Much of their equipment is just powered by DC. So through many of our controllers, we incorporate a load control circuit as well, so that they can monitor the current draw of their DC load operation. They can disconnect or power cycle loads remotely. And they can, again, this all prevents the battery from being over discharged. Generally, the choice of controller is going to have a profound impact on the life of your battery. So it's a decision that you don't want to take lightly. And, you know, obviously the wrong controller in many cases, you'll see that evidence in your lifespan of your batteries being, you know, a very costly investment. So you want to do everything you can to protect that investment, treat them as they intend to be treated. So as I mentioned, we are the leader in both types of controllers, those being maximum power point and pulse width modulation controllers. And all of them, I mean, you can distinguish between the technology in terms of which one is best for you, but all of them will result in longer battery life provide, increased storage of reserve power and increase the efficiency of solar harvesting. When you get into the specific behavior of the two different types of controller technologies, the MPPTs are sort of, a little bit newer in terms of the functionality. They have a little bit more advanced control in terms of their ability to efficiently conserve power, especially when you're using panels or solar panels that are larger, they have higher voltages. You want to have the MPPT controller variety so that you can efficiently step down the voltage conversion to charge your battery. You don't want to lose a lot of that valuable energy in stepping down between voltages. And so that's where the MPPT comes in handy. For instance, you can see illustrated here on this chart, on this graph here, each panel, in this case, we're looking at a 12-volt module, has a characteristic IV curve, current versus voltage. And the maximum power point is at the knee of this curve. Generally, for a 12-volt module, it'll be around 17 volts. If you're using a PWM controller, just by limitations of the circuit design, it can only elevate itself to operate at battery voltage. So it can only ever let the solar panel get up to battery voltage. In that case, if it's a 12-volt battery, your max battery voltage is going to be, somewhere around 15 volts. If it's lead acid, for lithium, a bit lower. But in that case, you're losing a lot of this additional power sliver here that could be gained if you were able to operate the array at a higher voltage than the battery. So that's what the MPPTs allow you to do. And you can see the performance advantages, typically 5 to 15% additional energy harvested in your battery. So for certain conditions and climates, it makes sense to use that technology. So really every day at Morningstar, we have encountered, and it's growing every day, 30% is what we calculated for our customer system inquiries are now inquiring about the use of lithium for remote solar applications. Again, a lot of what they're drawn to is the extended cycle life rating, the ability to tolerate partial state of charge, and avoid costly maintenance if they can just run autonomously for longer periods of time. And so, again, at Morningstar, what we decided to do is, through all this feedback and wanting more information about lithium integration, we decided to create a program called the Energy Storage Partners Program, and we're proud to have Fortress Power as a member of that program. We work closely with them. We've vetted many of their batteries and provide charge settings recommendations based on testing and what we have worked in collaboration with Fortress Power to document for our users. And so all of that information is accessible on our website through the Energy Storage Partner Program page. You can find under our resources tab, and you can download links to many different documents from a number of manufacturers that outline the settings requirements for lithium integration. We'll talk about that coming up. All of this was primarily intended to assure the system designers that our products are compatible, interoperable. We wanted to, reduce the time and effort that they spend on site, installers, trying to figure this out, how to program them accordingly. We've really tried to take the hassle out of the process for you. And again, the end users then can have more peace of mind that the combination of products they are using is proven, it's been well documented and, vetted by both companies. So with that said, I will go ahead and turn it back over to you, Alex.
Thanks, Jake. Very well said. So now what I'm going to do is I'm going to do a poll. So everybody get ready for the poll I'm going to send out. And take a minute and read through that. And we're very interested to see where everybody ranges from using lithium batteries to never using lithium batteries to just thinking about them. So I'll wait here a minute. Everybody submit a quick vote and we'll get going. Okay, I'm going to close it in 3, 2, 1. Last minute. Close the poll. So we had 35% have been using lithium batteries. We had 15% have never used lithium batteries, and the remaining 49% are thinking about using lithium batteries. So thank you for joining us on that poll. I think it's important to see where different people range from using lithium batteries to thinking about it to never. I think as lithium batteries, like I mentioned in the first half of the presentation, get more deployment, hopefully we can get some of these people thinking about it to have been using them. So that being said, thank you again, and I'm gonna continue on with the battery technology comparison section of my presentation. So we incorporate the safest technology into our battery systems. So you can see here on the left, we incorporate a lithium ferro or lithium iron phosphate chemistry. So how is this different than what the Tesla or the humblest battery uses? So the lithium phosphate chemistry is much safer than the lithium cobalt chemistry that Tesla uses. I'm sure we've all seen the videos of the thermal runaway cases with Tesla. So it's why, especially for a standstill energy storage where it's going to be in someone's house and they want a lot of cycles out of it and a lot of safety, the phosphate chemistry certainly makes a lot of sense. Lithium iron phosphate is also eco-friendly. It can be recycled, and like I mentioned, it is more thermally stable. It has a lot longer life cycles, so 6,000 cycles in comparison to around the 3,000 cycles of the cobalt chemistry. And then the lithium polymer chemistry, on the other hand, is like the battery that is in your phone. So for those of you that have terrible battery life and on your phones like yours truly, you'll know that over life, as you continue to charge and discharge your phone, you're not really getting the life cycles that you're supposed to be getting. So when it comes down to safety and recyclability and thermal stability, phosphate chemistry certainly makes sense. However, that being said, to be fair, I think it makes sense that the lithium cobalt chemistry, like what Tesla uses in their electric cars, definitely makes sense, right? They need a lot of energy to move a car from point A to point B. So for different transportation applications, I definitely do think the cobalt chemistry makes sense. Now for something for like a stationary application where you want a lot of cycles, because you'll be cycling it every day to power different electrical loads, this is where we see the benefit of the phosphate chemistry. So you'll see that the degradation rate of the phosphate is less than that of the cobalt chemistry and less than that of the polymer chemistry. Now you can see it's not as energy dense as the cobalt or the polymer, but that is the trade-off. It's not as energy dense, but it is more safe. So that is kind of what I meant when I said it's not as energy dense, so it does make sense to have it in a standstill energy storage, but something where you need a lot of energy density to move, a pretty heavy car from point A to point B. This is where the lithium cobalt chemistry definitely makes sense in that kind of regard. So keep that in mind as you look at some different batteries and different technologies and choosing between them. So if anybody has seen this video, it's a pretty interesting video I like to recommend people to watch. It's LFP versus NMC nail test video on YouTube. Essentially what they do is they have two kinds of cells. They have an LFP cell, as seen here on the left, and an NMC cell here, as seen on the right. So the LFP cell, they drill a 10 penny-inch nail right through the center. Now you'll see throughout the video, there is some smoke and it smokes a little bit, and then towards the end of the video, they pull it out, nothing happens. Now, if you look here on the NMC cell, they do the same thing, and it goes full-blown apocalyptic. So just showing that if there are concerns regarding, the lithium battery or the lithium cell themselves, the high safety of the phosphate chemistry, where you can really drill a nail through the center, will definitely put you at ease when considering a lithium battery to put into your home. So keep that in mind, and feel welcome to view the whole video, the full 3 minutes and 38 seconds LFP versus NMC nail test video. So why lithium? Question I get almost every day. So has a long lifespan, like I mentioned, the 6,000 cycles. It has a low energy cost in the long term. So for the dollars per kilowatt hours that you're getting is much lower than the other chemistries. It has a 98% round trip efficiency. It's compact and lightweight, and there is no ventilation needed. With no ventilation, I mean it doesn't have to have a ventilation tube there is no off gassing or anything like that, and there is no maintenance. So, if it's a flooded lead acid, you have to refill it with water, or if it's a nickel battery, you have to do maintenance on that. There is no maintenance with phosphate chemistry. You're able to discharge it 100%, and also has a fast charging and discharging rate. There's a consistent discharge power. So if you guys check out this little chart I have down here on the left, this green line is LFP. So what this is representing, this is current on the bottom, and then this is amperage. So this is saying that 100, as your current goes up, your capacity is going to stay consistent. So it's meaning that you can discharge a lot of current and your capacity will stay the same. But if you have a flooded lead acid or an AGM or a gel, then you can see here that as your current goes up, let's say you're pushing current to a specific load in the house, your capacity is going to drop. So for example, if you have a 50 amp and you're pushing 50 amps through a lead acid, and let's say it's fully charged here, you're actually getting less amount of power at that 50 amps when you're pushing it there. It means that you're not going to have the actual capacity that the nameplate of that lead acid battery is. So keep that in mind. LFP is straight across the board, while a lot of these lead acids, as your current goes up, your capacity will drop. So I'm going to go over a quick 3 of these performance comparison of the LFP versus the lead acid system. So just went over this one here. So this was the discharge amps and then capacity that I mentioned. LFP is also less affected by temperature. So LFP has a very broad discharging temperature. You can see that even if you get into the 32 degrees Fahrenheit, normally the batteries are indoor used, so everybody knows, but should it be into 32 degrees Fahrenheit, it's not going to stop the charging or the discharging. It's just going to affect the rate and the capacity of the battery. So it's definitely not going to affect as much on the temperature side. It'll just affect, you'll have to account for that if certain loads, if it does get cold, just note that your capacity will drop as your temperature gets lower. And then I mentioned the cycle life in relation to the depth of discharge. So we are this green line here in the middle. So an 80% depth of discharge, we can usually guarantee around 6,000 cycles. And then the same thing, if you want to do 50%, you could get more, and then 100%, you could get less. You can go into like a 90% DOD if you want somewhere in the middle. A word of caution to everybody. There are some battery manufacturers out there that say they can reach up to 10,000, 12,000, 14,000 cycle lives. I always tell people to be aware that although it's a great thing to say, 12,000 cycle lives, you have to be careful what they're telling you. Is this assuming a 50% depth of discharge? Is this taking into account temperature? Is this taking into account, the different charging and discharging parameters and the project itself? So just be wary or at least be cautious when, you are choosing a battery, that the cycle life is not only protected by the warranty, but also is taken into account a realistic project. So we're in this middle, and I have seen people go to 100%, but we usually recommend 80% for the 6,000 cycles for the 10-year warranty that we provide. And then if you look at the space comparison between the LFP and an AGM battery, this is our eVault 18.5 kilowatt hour unit here. And this is some AGM batteries here on the left. So you can see here, this is only 250 amp hours or 6 kilowatt hours of usable power. And here are the eVault, maybe half the size, maybe these 4 here in terms of size, but also has, almost 110 more amp hours and 12.5 kilowatt hours more of usable power. So not only is it a third of the size, or a third of the weight, I mean, it's also a third of the size. So in places where you don't have a huge utility room or there's not a lot of space, this is where LFP can be an advantage, because you can really get a lot more bang for your buck in a smaller space. So quickly, I'll go over a quick comparison of all the different battery technologies on the market. So here I have LFP, lithium-ion, lithium polymer, like I talked about earlier, some flooded lead acid batteries, AGM, and the nickel iron. So a few things I would like to kind of point out here. The first one is energy throughput. Now, what is energy throughput? Energy throughput is the total amount of energy a battery can be expected to store and deliver over its lifetime. So we're saying here that our LFP battery, let's say the LFP10, has around 47 megawatt hours of energy that can be stored and delivered over its lifetime. The only one that's definitely comparable is this nickel iron battery. But then if you look at the cost, the homeowner cost of a 10 kilowatt hour battery, all things being consistent for the energy throughput at least, you can see this nickel iron is almost 2, maybe even 3 times the cost of the LFP. So LFP has that very high 98% round trip efficiency, 6,000 cycles at an 80% depth of discharge, 47 megawatt hours. And I mentioned the cost per kilowatt hours earlier. So this is really what you're paying per kilowatt hour. And LFP has one of, if not, the lowest cost per kilowatt hour because of the longevity of the chemistry itself. LFP is also very safe and free of maintenance, like I mentioned before, and has 16.4 years of off-grid usage. So the only one that would be comparable to that is this nickel iron, but when you then compare the round trip efficiency and cost, I think we can all see here the LFP battery is definitely one of the most competitive and probably the one I would recommend for most different project applications. Now that being said, to be fair, not one battery can cover all the different applications that are available. So do your research beforehand, check out the different pros and cons of the different battery technologies. I know other people have seen that LFP is just very flexible in that regard. So I guess overall, why lithium is certainly to be preferred is because of the superior safety of the phosphate chemistry, the high energy throughput, 47 megawatt hours here, long duration, 6,000 cycles at an 80% DOD, and the low energy cost. If you're interested in finding out energy throughput for other batteries that you're considering or taking a look at, you can find energy throughput by taking nominal capacity multiplied by the depth of discharge, multiplied by the efficiency, round trip efficiency, multiplied by the cycle life. So keep that in mind when looking at a battery. The energy throughput, something that's commonly not discussed about too much, but it really is a good indicator of how long your battery is going to last and what it's going to do over its lifetime. And we are compatible with the Morningstar group, obviously, and more of the integration and then the charger settings for their piece of equipment can be found on our website, www.fortresspower.com/resources. So as you can see here, for the different cycles that we have, you can put in the different recharge voltage, bulk voltage, and absorb voltage, and then the charge current for the different models we have. So for example, the eVault at 3,000 cycles would have 160 amps per battery, and at 6,000 cycles would be 100 amps per battery. So feel welcome to check this out on our website and some of the other resources with the parameter setting guides, installation manuals, and case studies to see what would make sense for your particular project. With that being said, Jake, I'm going to hand this back over to you and let you present.
All right. Thanks, Alex. I don't think I really need to review this slide much. I think Alex just summed it up really well. You can boil it down. Morningstar's boiled it down to basically 7 characteristics that, again, you want to be aware of in choosing, making a change from, say, conventional lead acid to newer lithium technology, and how that will affect the system behavior. So feel free to refer to this chart if you like, just as a quick reference. But basically what I'd like to talk about is more of the capabilities, features, and settings of Morningstar controllers that you will find that cater to various aspects of lithium integration. And so one thing, for example, you'll see the controller here is our TriStar MPPT, mid-range MPPT controller. Offers a lot of features and value. One of the features that caters well to lithium is what we call a low temperature holdback. And as is common with lithium batteries, there is a little bit of sensitivity in terms of charging in colder temperatures that you want to be aware of. It's not a problem. It's just something that you want to make sure is addressed appropriately, and with the compatibility on other products, including our controllers. So what we allow is the user to program a foldback D-rate. So what they can do in our custom settings is you can specify a high temperature and a low temperature threshold, specifying a range over which the controller's output will linearly derate as temperatures get colder. So it's nice in that it still allows you to harvest as much power as possible, continue charging the battery. Maybe temperatures, will pop back up. So you don't want to cut off the current completely, and you just have it operating on a linear spectrum. So if, say, for instance, your high temperature threshold is 10 degrees Celsius, you're going to want, and maybe you shouldn't be delivering any current to the battery below freezing temperatures or 0 degrees Celsius, then that should be your low temperature cutoff, 0 degrees Celsius. So when you specify the high as 10 degrees, the low at 0 degrees, you're going to get a linear D-rate of whatever the output current rating of the controller is, given, adequate solar resource. It's just going to perform that linear D-rate of the output current into the battery. It's a very nice feature. Also, you'll find some user-friendly options. We provide an optional interactive meter display with, arrow buttons for navigation, very user-friendly menu navigation. The settings are pretty straightforward and intuitive, but you can change many of the custom settings you can do on the fly right from the meter display. So you don't need to pull out a laptop and hook up a PC adapter to connect. You can do it all straight from the meter display. Also, there's a useful feature sometimes, depending on the level of sophistication for battery management systems, they may have the ability to send an alarm signal through a dry contact to drive a relay, connected to our controller. One of the access points that we provide is actually our RTS terminals, which would be for the remote temperature sensor. Typically, you're not going to be having temperature compensated charging with lithium batteries, but you can still use the RTS terminals connected to that dry contact, so that when the BMS trips on alarm or some low voltage condition, it can signal to the controller to turn off or stop charging. So that's a pretty nice application as well. And then you do have full programmability via USB. There's just a little communication adapter you can get from Morningstar called our UMC1, and that allows you to connect to our PC software called MSView. We'll take a look at that coming up shortly. And that has a really extensive list of more advanced custom settings capabilities, data logging, graphical analysis, all kinds of tools in that software package that you can have access to as well. And then voltage sense is something that has been unique for Morningstar products for a long time. I start to see competitors follow suit now because they realize that the accuracy of regulation can be drastically affected by voltage drop. And so you want to be measuring that voltage, the battery voltage, directly on the battery terminals. If your controller is positioned farther away or outside in a different enclosure, and there's some voltage drop in the wiring, you want to be able to compensate for that to maintain accurate regulation. So having the pair of voltage sense terminals on the controller allows you to do that easily, builds in a little bit more intelligence for the controller to do its job. This graph just illustrates the lithium foldback feature I was talking about. So you can again see here, I should have pulled it up as I was talking about it, but you can have this linear D rate approximating the curve. This curve, is provided by the battery manufacturer that says, okay, as temperatures get colder, we can accept this much current, we can accept this much current here and that much current there, and then you got to cut it off completely. So we can approximate that curve with a linear D rate with that low temperature foldback. And then there's also some advanced settings, as I mentioned about, you'll find in MS View. Some of them are available on the meter display as well, on the controllers that have those equipped. High voltage disconnect is one that we, again, as I mentioned before, many of our controllers are equipped with load control circuits and to run DC loads. So we can monitor the DC load draw from the battery as it is monitored by the controller. And what we have this setting built in, high voltage disconnect. It's a voltage threshold that specifies when the load needs to disconnect in order to prevent, some certain loads are more sensitive to higher voltages, especially in, telecommunications. So you want to be able to cut them off if the battery voltage is getting high and it's running off the battery. You want to be able to safely disconnect the load so it doesn't get damaged. So that's a useful feature. Max regulation voltage is good, although it's what it specifies is a max threshold on the battery side that your battery will never regulate to a voltage above that threshold. So, if you cut it off, if you specify the max regulation voltage is 15 volts, even with temperature compensation and really cold temperatures, it's not going to go above 15 volts, and hence the load connected to the load output terminals is not going to see that high, is not going to see a battery voltage higher than that 15 volts either. So it's a way of protecting both the load and the battery. And then absorption extension is really more of a feature geared toward lead acid batteries, just because there is sort of an associated memory effect with the depth of discharge, which, as Alex mentioned, you don't get that with lithium. It's very stable throughout. But with lead acid, if you went through a deeper discharge cycle one day down to, 30% state of charge, down to, 12 volts, you're going to want to be able to extend the absorption period the following day in order to recover that lost capacity. So there's no long-term lasting memory effect. That's what that setting is responsible for. And then, of course, being able to calibrate your temperature compensation coefficients and temperature range is nice to have as well. Again, with lithium, it's not as much needed. You're not compensating the charging output in different temperatures. But for lead acid, where you do have some elasticity in the behavior, you want to be able to dial that charging regulation so that dial it in as much as possible so that it's accurate throughout the temperature range specified. And you have full custom programmability within MS View to do that. So this really is just a comparison, open loop versus closed loop discussion. So everything we're talking about here with our integration with Fortress and all of our other lithium battery partners at this time is open loop. So again, it's utilizing all of our custom settings capabilities that are built into our software to manage the charging. Again, in accordance with the manufacturer's recommendations, but we are not directly talking to the battery. As Alex mentioned, I believe on a couple of their products, the E-Volt and the new E-Flex, they do have the option for closed loop communication, and so that will be something we'll be pursuing in the future so that we can actually iron out all of the settings and instructions straight from the battery to the charge controller in real-time control, and then the user won't have to program anything. It'll just happen automatically. So that's what we plan to get to eventually. But again, the open loop compatibility, it's been well vetted. The settings have been agreed upon by both parties, and we're very satisfied with the performance that it offers. There are some things, again, that come along with the closed loop management that would be advantageous. One of them is having true realistic state of charge interpretation. Right now, we are unable to retrieve that data, as I do know that it is available from the BMS for closed loop. But if you needed to get state of charge information as seen by the controller for just system level monitoring purposes, you would want to use an external battery shunt. And there are various shunt monitors that come equipped with digital meter displays that you can get as well from third parties. So just to go ahead, let me show you how simple and easy it is to locate the Fortress Power settings that we put together on our integration guide through our energy storage partner program. You just go to our website. You can go to this direct link, or you can find it under the resources tab on our homepage, the energy storage partner program. When you go to that page, you scroll down to the bottom, you'll see a form, and you'll go ahead and you'll see a bunch of brands listed. Go ahead and find Fortress on the list and click the checkbox, and you fill out just a little bit of personal identification, and then submit the form. You'll immediately get access to the PDF download of the integration guide from that vendor. And then you go ahead and open up the document. In it, again, you'll see a list of all the settings, both optional and recommended. And so you'll see those listed, and then you'll also, toward the bottom of the document, see a list of resources with downloadable links. You'll go ahead and click on the one that says MSView configuration files, so you can initiate the download of a zip folder that has all of the pre-populated settings files for each of the controllers that is compatible with that battery vendor. So when you go next, you'll go ahead and extract the file contents. You'll go ahead and give it a destination and just remember where you put it. If you just want to put it on your desktop, go ahead and click extract. And for those of you that are new to MSView is our programming software. To get it, it's free. You just go to our website, click on the products tab, and you scroll down to MSView. Click on that link right there, and there's a click here hyperlink that will initiate the download of the software. So you can go ahead and do that, get it running on your desktop. Once it's fully installed, open it up. And what you'll want to do is, once you get a physical connection to the controller, again, if it's just a direct serial connection to your PC using a USB adapter, go ahead and connect that from the controller to your PC. You'll go ahead and go to the Devices tab and click Search for Connected Devices, and it'll run an automatic search in which it should locate the connected device. You go ahead and select, so you can see here I had multiple devices that were connected on our local area network, but if you're just connecting one device via serial, you'll just have that one device pop up. Go ahead and click Connect. When you do, you should see it pop up in the left-hand sidebar here, and the little icon next to it should turn green. If it doesn't, you just go ahead and double click on it and press Connect again. Sometimes it may wait for the user to connect manually. But anyway, once you do that, you'll go ahead and select the appropriate setup wizard for the controller that you are connected to. So in this case, it's the TriStar MPPT. So I'll go ahead and open the TriStar MPPT setup wizard. And you'll go ahead and this little dialog box will come up. You'll go ahead and click the Read from File button. And so then that should give you, this window will pop up. You'll have to locate the zip folder, the location where you have the zip folder for the Fortress Power configuration files. It should automatically populate the one, if you're within the TriStar MPPT setup wizard, the file appendage is the TS MPPT. So that it should automatically populate that file, and you just go ahead and click Open. And then once you do that, then is the time to go ahead and add any other settings that you want to customize specifically for your application. If you need to do anything with lighting control, or you need to add in, the low temperature foldback, you can do that here. Those are all, dependent on the user to implement. But if you like everything the way it is, you can go ahead and just finish the setup wizard, and you can go ahead and click Program TS MPPT. And that will, a window will pop up that basically just takes you through, some prompts telling you when to power cycle the controller in order for the new settings to take effect. And that's as simple as it is. So anyway, I hope that, you will find those settings useful. We certainly encourage you to use them. Again, they're completely free. We just wanted to do it to help save the user and the installer time, spent on site just fumbling through manuals, trying to figure out what the recommended settings are from one manufacturer to the next, getting tossed around between vendors. It can be a real headache. So we tried to take a lot of the guesswork out of it for you. Just to kind of sum things up, when you're looking at different battery technologies, again, I know, Fortress and the extent of our integration relates to lithium batteries. There, as you could see from Alex's comparison, there's a lot of differences in terms of expected lifespan between battery chemistries, the maintenance requirements, and your available space and budget all have an impact on which chemistry to use. So definitely consider all of those when you're making your decision. Whether it is lead acid or lithium, you got to make sure that you're charging it the way that the manufacturer says it needs to be charged. They know best, since they designed it, they've tested it. You want to make sure you get the information straight from them. Of course, we've done that for you, as we are closely in contact with Fortress to vet these settings and make sure the integration is successful. And again, you have plenty of additional capabilities from Morningstar, regardless of what your needs are. your charging needs. Even if they change in the future, you have free custom programmability at your fingertips, interactive meter displays that make it very easy to change. So with that said, I guess I will go ahead and pass it back over to Jamie. I think we probably had a number of questions that came in, so she wants to read them off, and we'll be happy to answer them for you.
Yes, we do have quite a few questions. So we're going to start from the beginning. So I have the first question here is, please explain the Fortress Power BMS, battery management system. Does the Morningstar sell any BMS for, say, several banks of 12-volt batteries assembled into 48-volt packs? Let me know if you need to hear that again.
Is that one you want me to take?
Well, I think this is for both. It says, please explain the Fortress Power BMS battery management system. That would be for Alex. And then the second part is, does Morningstar sell any BMS for, say, several banks of 12-volt batteries assembled into 48-volt packs?
Okay. I was going to say the BMS is essentially, it's built into the battery. So respectively, like I mentioned, the contactor-based BMS is something that's found in the battery itself, which will essentially do constant readings on the battery to protect it against those things I mentioned. So like the overcharging and discharging, over temperature, things like that. So essentially it's a, on the MOSFET base, it's a circuit board. And then on the contactor base, it's a fuse and a switch that constantly reads what's going on in the battery to protect the battery from those things I mentioned earlier.
Yeah, and from our perspective, the second part of that question, yeah, Morningstar doesn't supply any of the BMS components externally. Again, there may be certain vendors out there that offer external BMS, and you can kind of build your own battery bank if you're that adventurous. I know some folks have come to us with like recycled EV batteries, electric cars. They, of course, operate at higher voltage, but they want to repurpose it for off-grid to run some of their household loads. And so they'll just configure it down to 48 volts instead of, 380 volts or whatever it is. And then, you don't want to just leave it at that, get rid of the cells you don't need or whatever. You want to make sure that you have a BMS that is properly configured for that new configuration of that battery bank. So again, I don't believe Fortress would have these battery management systems sold separately. There are a few vendors in Europe that do that if you're into a sort of build it yourself type battery scenario. But I always urge customers to just go with the BMS that is built in to the battery. Vendors such as Fortress really know and understand their product much better than anything else. And again, it's not a decision you want to take lightly. So in the wrong hands, if you didn't know what you were doing. So I trust the experts. I would leave it to Fortress and, just get a battery from them. Everything is already in there, and it's a reliable package.
Mm-hmm. Yeah, and I think Jake, you hit the nail on the head there. There are other options that you could use, but normally, usually with batteries, at least the BMS is built into the battery. It's approved. It has seamless connection. I think the only thing we would be concerned about from our point of view is getting a BMS from somebody else. You don't know if their warranty covers that. You don't know the quality of that. So certainly possible, but just be aware of those different things.
Okay. I have a question here from Tim. Does Morningstar have a 208-volt three-phase inverter?
Tim, unfortunately, we do not. Again, as I mentioned, throughout our 27 years of existence to this point, we've been focusing mostly on charge controllers. We have, the one little inverter you saw earlier in one diagram. We are coming out with a new inverter. I don't have a specific launch date to give you yet, but it will be single phase primarily at first. We do plan to implement split phase as well, but I don't know whether we'll get to 3-phase, at least, any in the near term future. But it is something that we'd certainly like to consider for more commercial applications. But I'm sure Fortress could refer you to another manufacturer that does have 3-phase inverters. Maybe they would be willing to do that.
Yeah, if you just write into us and let us know the project, and if it is 3-phase, what size, I'm sure I could find something for y'all.
Okay. Next question is from Wayne. What is your end of useful life criteria for the cycle life test at 80% DOD?
So I think my answer is going to include it has a 70% retention capacity at the end of the 10-year warranty. So it's assuming all things being consistent, at the end of the 10-year warranty of our batteries, we'll have 70% retention of capacity.
Okay. Next question is, what options are available for use in hazardous location, like Class 1 Division 2 Group D?
Sure. I can take that from our side, at least. The Morningstar does offer a couple different controllers for, they come in the PWM variety that we talked about, being most common for the hazardous locations. Our Sunkeeper and our Sunsaver product lines are both Class 1 Division 2 rated, certified. So those would be applicable for those types of environments. However, those products themselves do not currently have custom programmability for lithium. I'm not 100% sure what the battery requirements are for Class 1 Div 2, if it's more just based on housing them inside an enclosure that is properly rated and so forth. But we are looking at potentially broadening the range of Class 1 Division 2 offerings to include more data-enabled capabilities that would lend themselves to lithium compatibility. So that is something we will be considering, hopefully in the not too distant future.
Okay. The next question here is, while in operation, is it mandatory to place the lithium batteries under controlled temperature environment? If batteries are kept in operation at higher temperature, how much is the cycle life affected?
So I'll take this one. Usually it's recommended that it is in a somewhat temperature controlled environment. Like I mentioned, the batteries are indoor rated primarily. So, that being said, if they are indoor, more often than not, they are in somewhat of a temperature controlled environment. If they are kept at a higher temperature, the cycle life might be affected a little bit. You might lose a little bit of life cycles, but that's only if it's consistently. If it's kept at a higher temperature throughout, the 10 years of usage, it might affect the cycle life just a little bit. Instead of 6,000 cycles, maybe expect 5,500, something along those lines. So nothing too, I'd say serious, but it is something where we really recommend it keeping between that, 32 degrees Fahrenheit and 113 degrees Fahrenheit range.
Okay. Let me see. Hold on. We have a couple more that just came in. Does Morningstar have any plans to offer versions of the software for Android, Apple, etc.?
Well, that's a good question. So right now, for our existing product line, we're primarily, MSView is a Windows-based utility. So you do need to be running a Windows operating system or emulator. You can run, I think it's Wine, which is it says it's not an emulator, but it basically is Wine for Mac. So you can basically run Windows and utilize our MSU software that way if you want. in the future, I think what we're looking at more for newer products is having a web-based utility, agnostic of operating system. So again, anything with a web browser. We currently have our LiveView software that is available on our TriStar MPPT 60s that have a built-in Ethernet port. That actually right now is for sort of view only. It's just a status display readout. It's not fully bidirectional in terms of a programming interface, but we are looking to basically build that out to incorporate programming capabilities in the future, you know, for Ethernet-enabled products. So that will probably be the way we go. But for now, the legacy MSView software is just for Windows PCs only.
Okay. Question just came in. Is the warranty offered guaranteed by Morningstar or by Fortress, or treated separately?
Separately.
Well, that's a great question. I would say treated separately. Again, I mean, each of our components has its own independent manufacturer warranty, 5 years for most of our products. And again, Fortress, I guess you said it's 10 years for your standard warranty?
Yep.
So they would be independent. Of course, you know, when it comes to technical support and troubleshooting, if you did need that, you know, both of us are connected in terms of knowing who the support teams are. We have easy access to those resources. So if there is a problem in the field, being able to diagnose it quickly, whether it's an issue with the battery or the controller, both of our teams are well versed in being able to support that.
Okay, and I think we're going to take one last question here. How to communicate with Morningstar remotely via wireless communication? What devices should be used? Where can I find this information?
So with the wireless communication, currently our communication options are hardwired mostly. So if you're communicating on an IP network, we have our Ethernet. A couple of our products come with a built-in Ethernet functionality, so they can be connected to your router and to the internet, or just a local area network if you want. And then some of them that don't have standard Ethernet built in can utilize our EMC1 accessory gateway device. So that is sort of a IP gateway that is used to retrofit Ethernet access to some of the smaller or older products that just have our meter bus port, which is like the RJ11. So it converts the RJ11 into RJ45 for Ethernet output. Those would be the main products that would be needed in terms of being able to communicate on an IP network. If you have a wireless gateway outside of that, you can certainly, you know, connect to it either locally or remotely, depending on what you're using. We don't have any direct Wi-Fi access point built in to our controllers. That is also something we'll probably look at in the future, Wi-Fi or Bluetooth or something of the like. But right now, the wireless connection would just be on the IP side, not a direct connection to the controller.
Got it. If you guys can go to the last slide really quick. Okay, so if anybody has any questions, please email Fortress Power at sales@fortresspower.com and Morningstar at info@morningstar.com. Again, you will be receiving a copy of this presentation along with a link to the audio recording of this presentation. Thank you so much for everybody who joined us, and we will talk to you again soon.
Yeah, thank you, everybody. Thank you, Jake, from Morningstar and the Morningstar team for setting this up with us. And Hope everybody got their answer. Everybody will get their questions answered.
Thanks again.